Now your MAC address and ARP protocol is the next topic that we need to discuss. Moving forward, basically what you have is your IP address is 32-bit that you've already seen from your network layers that you talked about. Your MAC address is basically 48. That is what we discussed in the previous class. Again, this is how your LANs are connected and your devices are connected using the MAC address and the broadcast address. Now, the first thing that you need to look into is the what do you mean by an ARP protocol? Now, for to send a particular data, you require two addresses basically. You require the IP address and you require the corresponding MAC address. So the question two is how to determine the MAC address of the provider you know your IP address. So basically, this fellow wants to transmit something to this particular fellow. So it needs to have both its IP address if it wants to originate, send data from a source to the destination. So source IP address, destination IP address is required. Source MAC address, destination MAC address is required. So provided you have an IP address, if you want to know the MAC address, the protocol that you want going to run over there is an address resolution protocol, an ARP protocol. So you have a table, an ARP table, where it is a table that says this is the IP address and the corresponding MAC address is this. And each new value I get, that is being updated to that particular ARP table. Might be you can associate a time to live. That means that mapping can be might be refreshed after a certain point of time, so that there might be no loops and all the structure to it. How does it work? Basically, this is the basic thing. How does it work? Now, A wants to send some datagram to B, and B's MAC address is not there in A's ARP table. So what does it do? It says A broadcast a query saying that containing B's IP address. So what it does is it sends the destination MAC as FFFF and with the IP address also. So since you're broadcasting it, every node sees it. Now every node sees it, but only B will respond because B knows that it is its MAC, right? Its IP address. So it receives that particular particular frame and replies to that particular frame with its MAC address. Now, when A receives that particular frame from B, it saves that particular MAC address of B in its table, and then it sends its actual data with the source address, IP address of B as MAC address, and finally the destination, source address of A with IP and MAC, and to B, the destination address, IP address, and MAC address. Okay, so this is the basic structure over here. Now, if you want to draw it in a diagrammatic manner, you can draw it also. Now, assuming that, so you have A and B. In your previous diagram, what you were talking about is, we're talking about one network itself. We're talking about this particular stage here. Just say that, no, this is A and this was C, and A wants to send something to C, and A doesn't know C's MAC address. What does it do? It broadcasts. It broadcasts, and the broadcast address would be all F, but with IP address would be this. So C will get that, and it will send back a message to A saying that, yeah, fine, this is my IP address and this is my corresponding MAC. It updates its table, and finally it will send its information to C. So you find that little bit doubtful, but just assume that is possible. That is again thing because there are other nodes in this particular device also. C, D, sorry, since that is happening again, D, E, and a lot of networks. So A will be broadcasting information that will be received by, that will be seen by E, and that will be seen by D, everybody, but only since the IP address is of C, only that will respond back. And once that is done, it will be sending an actual data to C and will be communicating. Okay, that is when they both are the same network. Now, this example says that A is in this particular network as well as B is in this particular network. How does it go? You can say you can divide this into two halves basically. Okay, this is two halves. So A will be broadcasting with what do you say? Its source address, IP address, and its MAC address, and the IP address of B. IP address of B with the broadcast. So all these nodes, if there are other nodes also, they all will not respond. Who will respond? This particular router's interface will be responding, saying that, yeah, I've seen this fellow over here. So what does it do? It forwards this particular information to this interface. So you have two interfaces. This is one interface and this is one interface. This interface to this network, this interface to this particular network. Now you have that information coming over here, and that is again circulated over this particular network. IP address, and it is broadcasted. And since it is B's IP address and is broadcasted over here, B will respond. B will respond and give that information to this particular interface. That will be again forwarded to this interface, and that will be forwarded to A. Now A knows what? A has its own IP address and MAC address and knows the IP address and MAC of B. Now we can send that information directly, then goes and reaches B. This is an address resolution protocol, and that is working across different networks. The first was within the network. Now it was across the network. This is an explanation to what we are just mentioned. You can go to that. You have another protocol that is known as the RARP. Basically, since it is there coming in your syllabus, we are mentioning it. Basically, this does not exist now, this particular protocol. Only the ARP protocol exists. And this happens when you have a diskless system and you just have the MAC address, but you don't have the IP address. So this works for that particular structure. One requirement that you should be drawing when you get this particular ARP or RARP question is this packet encapsulation and frame structure, please note. So this is for an ARP packet. What happens is that you have this particular thing comes with hardware type protocol, hardware length, protocol length, operation, whether it is request or reply. So I want to search for something. So it's basically a request. If I get a reply, so that will be 1 and 2. And you have the sender's address. You have the sender's protocol address. So if it is A who is transmitting, it's it's hardware address, MAC address. So this is basically, in your case, it'll be basically MAC address, and this is your IP address. So who is sending? If A is sending it, so A is MAC address and IP address. And if it is to somebody that you don't know, so it'll be the target hardware address. So if it initially would be basically what? It'll be all FFF because you don't know the target address. And then you have the target IP address that you guys know. So this will be your ARP structure. All these things are basic hardware, protocol, and all those things of it. These are the 4 things that you should be knowing. A is MAC address and IP address. Since initially it is just, you don't know who you want to send to, it will be basically a broadcast address, that means all F, and the IP address. And this is what? This is nothing but your frame format. So the source destination address, you have your source address, the type, and data would be your this particular frame that you're going to put over here. And you have your CRC and you have your preamble that you are appending over here. Now, if it is an RARP, the only difference that you can see over here is that you don't know your IP address. Okay, right? So the sender knows its MAC address, but it doesn't know its IP address because it is diskless. So what does it do? The first 2 parts are almost the same. Only thing is that its operation, the value to that is request is 3 and reply is 4. Other than that, these are almost the same. Difference is the sender knows its MAC address, but it doesn't know its IP address. It knows the target address and the target protocol address because you say that this is your server address where your information is lying. So it knows the hardware address of the server and hardware address of the IP address of the